In Kubernetes, the task of managing containers, where they run, the nodes upon which they run, and the like is handled by the Kubernetes runtime based on input from you in your deployment file. You've seen some simple deployments up to now, and we'll get into more sophisticated ones soon. In Kubernetes, the master, or masters, you can have multiple masters for reliability and scale. We'll get into that later. The masters control any number of nodes. These nodes are individual machines that run pods. End users, then, through services we declare, you may remember doing this in the previous example, access our application directly on the nodes. Don't worry about each individual component inside the masters and nodes for now. We'll go over each in turn later. Just take away from this that the masters control a variety of nodes and the pods running on them based on your deployment. Since containers and container orchestration technologies de-emphasize the role of the individual system, whether that's a server, a VM, or even a container, it can be difficult to get a starting point when exploring Kubernetes architecture. You'll remember the pod and deployment are relatively important concepts in Kubernetes from previous lectures and examples we've worked through. But let's think a little bit lower level for now and start with a familiar concept, the server or the virtual machine. In traditional architectures, it was usually the center of the universe. In Kubernetes, they're still quite important. They're called nodes. They used to be called minions, so you may see that in some older documentation, but now we refer to them as nodes. A node is a worker machine in Kubernetes. A node can be a VM or even a physical machine. Each node, regardless of what it is, has the services necessary to run pods and is managed by the master components. We'll discuss these later. Remember, masters just decide where to run your application. Kubernetes can consist of any number of nodes. It varies depending on your needs. We'll get into how you specify how many to run, what types to run, and how Kubernetes chooses what pods to run on what nodes and the like later. Don't worry about those details for now. But just remember, each node has a common set of services at the very least, regardless of what pods it may be running, that allow the master to send it work to do. These include Docker, a service called Kubelet, and a service called Proxy. Kubelet watches and manages processes on an individual node. You can think of it as the supervisor for that machine. It has one job. Given a set of pods to run from a master, make sure they're running. Kubelet runs pods. Proxy is the glue on each node that makes sure the network services exposed by each pod on the node can be accessed as defined in the deployment. You may recall when we set up a Tomcat service, we created a node port service to allow the outside world to connect to it on port 8080. Proxy was the glue that made that happen. Let's review how this all fits together. First, you deploy an application to Kubernetes. We've done this before. Initially and internally, the master will evaluate your deployment descriptor and decide where and how to run it. It will direct Kubelet on the appropriate node or nodes, depending on if the deployment asks for multiple replicas, to run the pods. Second, you define a service so users can access it. We've done this before too. The master will create connections between an external load balancer and external IP. For example, if you're running on a public cloud, it will direct the Proxy on each pod to connect to this given API or service, and the pods on each node. Finally, end users can access the services appropriately, as the load balancer will decide which pod to send it to based on the configuration created by the master during the deployment.